And in the yesterday's class, just a brief review on the last class what we discussed. That is Hadoop. Uh, we have discussed about the introduction to Hadoop, Hadoop nodes and daemons, Hadoop architecture, and the characteristics of Hadoop, Hadoop features, the technology that empowers Yahoo, Facebook, Twitter, Walmart, and all the big companies are using this same technology, that is Hadoop. What is Hadoop? It is an open source framework that allows distributed processing of large datasets across the cluster of commodity hardware. So here, open source means the source code is freely available. It may be redistributed and modified. So this was redistributed by, that means the standardized by Apache Foundation. So that is a standard which all the software companies used to follow. And then distributed means data is processed distributedly on multiple nodes, servers, multiple machines process the data independently. So there is no dependence on the other machines. So that is called a distributed processing because the data's volume is very large. And then cluster means it is a group of computers or the multiple machines connected together. Nodes are connected via LAN, WAN, the network. The commodity hardware means economic and affordable machines, typically low performance hardware. So that's how this is, provides us the economic and cost wise. And open source framework written in Java. This complete Hadoop was written in Java. And it was inspired by Google's MapReduce programming model as well as GFS, Google File System. As we have discussed all these, the evolution of Hadoop history. That's how that was evolved from 2002. Dog cutting started working on this Hadoop framework that was based on the GFS, that is Google File System. Then later on it was evolved and then it was used by different companies. Now all the other cloud platforms also adopted the same architecture, that is Hadoop architecture by AWS, GCP, IBM, and also Azure. So this became a top level project. It was defeated supercomputer. So as I told you, this contains three main components, mainly two components, that is HDFS, Hadoop file system, and the MapReduce. So what is HDFS? See, we'll discuss about HDFS first. What is HDFS? It's Hadoop Distributed File System. As we know, it is very difficult to maintain huge volumes of data in a single machine. Therefore, it becomes necessary to break down the data into smaller chunks and store it in a multiple machines. So this Hadoop, that HDFS file system, is the storage component of Hadoop. All data stored on Hadoop is distributed manner across a cluster of machines, but it has few properties that define its existence. Okay, so these file systems manages the storage across the network of machines that are called distributed file system. So file systems that manage storage across network of machines are called distributed file system. Okay, so this is called distributed file system, and HDFS is the storage component of Hadoop, and it has a few properties that define its existence. That is because it contains huge volumes. Being a distributed file system, it is highly capable of storing petabytes of data without any glitches. And then data access. It is based on a philosophy of the most effective data processing pattern, that is written once and the read many times. So written once, read many times. This is a pattern that follows. This HDFS follows. Okay. Then cost effective. HDFS runs on cluster of commodity hardware, as we discussed in the last session. So this is a cost effective. Okay. As the HDFS runs on a cluster of commodity hardware. Okay. These are the inexpensive machines that can be bought from any vendor. Okay. And what are the different components of Hadoop file system? There are basically Hadoop has two main components. Okay, Hadoop has that is sorry, HDFS has two main components. Those are data blocks and nodes to store data blocks. Okay, that means HDFS is breaks down into the smaller units of data. So each of these units is stored in different machines in the cluster form. Okay, and here these smaller units are called blocks in HDFS, and the size of each block is divided into 128 MB. Okay, these smaller units are the blocks in HDFS. Okay, and the size of the size of each of these blocks is 128 MB by default. Okay, you can easily change it according to the requirement. So if you had a file size of 512 MB, okay, and it would be divided into how many blocks? 4 blocks, right? 4 blocks storing each 128 MB data. Okay, so for example, if you look at this, for example, if you say this is a file, okay, this is a single file. Let us say file is a file, and this is divided into how many blocks? 512 MB file. Suppose let us say that file contains 120 MB of size. Okay, now this is divided into here four blocks. Okay. Sorry. Here, this is another block. So this is again here. This is 128 MB. And again, sorry, it's taking some time. Okay, like that again here also it is containing here also 128 MB, and here also 128 MB, and here also 128 MB. Okay, so this is divided into 4 parts now. So this is how the blocks are located in HDFS file system. Okay, if you had, suppose if you had a 524 MB of data, again it would be divided into 5 blocks. Okay, 4 of these would be storing 128 each, and the remaining 12 MB is going to store in other block. Okay, suppose if you have only, one 512 MB, this is okay. But if you have 524 MB of data, then this can be again here the other block will be created. That block contains the remaining data, that is 12 MB of data. Okay, so this is how in the HDFS file system the blocks are divided. Okay, and there are several perks to store the data blocks rather than saving the complete file. The file itself would be too large to store on any single disk alone. Therefore, it is prudent to spread it across different machines on a cluster. Okay, it would also be enable a proper spread of the workload and prevent the choke of a single machine by taking advantage of parallelism. So that is called distributed processing. Okay. So this is the file system which is maintained in the HDFS. Okay, and this HDFS all are there. Yeah, Nishant joined. Okay, here HDFS operates. This is a very important concept. HDFS operates in a master worker or slave architecture. Okay, this means there are one master node and several worker nodes. In the cluster. Okay, remember this one. The master node is the name of that node is name node. Okay, name node is the master node. This master node or the name node manages the file system namespace, which is the file system tree of hierarchy, files and directories. Nothing but it stores the metadata, data about data only. It doesn't store any data. Okay. And it is also aware of the locations of the blocks of a file and their size also. As we discussed here these are the blocks of each file. Okay, and the size of each block is stored in this name nodes or the master nodes. Okay, that runs on a separate node in the cluster. Okay, it contains the data about the data, not the actual data. The actual data is stored in the worker nodes or the slave nodes. Okay, and what it stores again, that it stores the file system architecture, like the hierarchy of the files, directories, and its data and its information only, not the actual data. And also it also stores the file permissions and the owners of the files, etc. Okay, and it also aware of the locations of the all the blocks of the file and their size. Okay, all this information is maintained persistently over the local disk in the form of two files. Actually it has two files, that is fs image and edit log. Okay, this fs image stores the information about the files and directories in the file system. Okay, in this edit log, on the other hand, keeps track of all the written operations that the client performs. Okay, this is regularly updated to the in-memory metadata to serve the read requests. Okay, so whenever a client wants to write some information on this HDFS or read information from HDFS, it connects with the name node. The name node returns the location of the blocks to the client and that operation is carried out. Okay, and the data nodes, the data nodes, the other node name is data node. These data nodes are the worker nodes. Okay, they are inexpensive commodity hardware that can be easily added to the cluster. See, don't feel boring because it is the actual theory you need to understand and you need to learn. Based on this architecture only, the entire Hadoop systems are built or designed. Okay, these basics are very important. These data nodes are nothing but the worker nodes. So they are the inexpensive commodity hardware that can be easily added to the cluster. So as and when the data increases, you can add the other computer in the network because it is connected to the network, LAN or the WAN. Okay, and these data nodes are responsible for storing, retrieving, and replication and deletion, etc. Okay, so first one is, you need to remember one thing, that is these data nodes are worker nodes. They are inexpensive commodity hardware that can be easily added to the cluster. This is important thing. The other one is, the other properties of these data nodes are responsible for storing, retrieving, replicating, and deletion, etc. of blocks when asked by or when requested by the name node. Okay, this is how the file system, the HDFS, is made. That is no, that was the that is the architecture of this file system. Okay, and in addition to these two types of nodes in the cluster, there is also another node called the secondary name node. Okay, these secondary name nodes need to restart the name node, which will happen in the case of a failure. Suppose if the name node is failed, the secondary name node will take care of that job. Okay, this would mean that we have a copy of this FS image from disk to memory. Okay, and we would also have to copy the latest copy of this edit log to the FS image. Basically, we have seen here this FS image and the edit logs are the main parts of this HDFS file system. Okay, and this will be again stored in the secondary name node. Secondary name node is the another name node in the cluster whose main task is to regularly match the edit log with the FS image and produce checkpoints of the primary in-memory file system, the metadata. Okay, this is also referred to as checkpointing. This is also referred to as checkpointing. The secondary it is better to use the other notepad. Plus go to this one. Okay, this is better. Secondary name nodes is another node that present in the cluster whose main task is to regularly merge the edit log with the FS image and produce the checkpoints. Okay, that is the main task. See, let us see. Okay. Okay, let us not go into deep again because we'll be confusing that we will learn whenever practice this in our practical sessions. Okay, so this is about the HDFS file system architecture. So let us see one image. I have stored it in a this is how you can see this. This is the primary name node. This is secondary name node. This primary name node contains the edit log FS image, and this is nothing but it contains only the metadata about the data, and also the secondary node also contains the same kind of primary node names data, and it continuously retrieves, edit and store that FS image from the primary name node. If this primary name node fails, automatically that can be recovered with the help of this secondary name node. So it manages with the help of this checkpoint concept. Okay, this secondary node is another node present in the cluster. And again, the other, so this is a storage, right? And we have, now coming to big data storage is by using this HDFS file system. The other one is processing is required, right? Processing. So this is done by, what is that we had discussed in the last session, that is map reduce. Okay, this is also a very important concept. This map reduce is a programming model because it is a processing mechanism that processes the large data sets with a parallel distributed algorithm on a cluster. Okay, map reduce when occupied with HDFS can be used to handle this big data. Okay, This basic unit of information that is used in MapReduce is called the key pair value or the key value pair. Key value pair. This is very important. Key value pair. This is the basic unit of information used in MapReduce. Okay. All types of structured and unstructured data need to be translated to this basic unit before feeding the data to the MapReduce model. Okay, that you need to remember. As the name suggests here, MapReduce model consists of two separate routines, basically. That is, namely, map function and reduce function. See, you got this? See, MapReduce is a programming model for processing large data sets. I'll write this definition here so that you can remember this easily. It's a programming model for processing large data sets parallel distributed algorithm on a cluster. Okay, this is the actual definition of this MapReduce. And the MapReduce, when coupled with the HDFS, can be used to handle this big data. This is the so we have yesterday we have seen one example that I'll show you that example also yesterday. See, as I told you in the yesterday's session, the last session, sorry, that is the last session. I'll just why this is not opening. Okay, this is how the data is processed, right? To handle the big data problems. Here, this is the Hadoop file system. Their data, suppose let us say we have taken one Flipkart e-commerce portal that has the data in two databases, that is in MySQL and Oracle. The inventory data contains in this, the inventory data is stored in Oracle database, and this e-commerce application data is stored in MySQL. So this data warehouse contains all this data from these two sources. But apart from this, actually that CEO wants to know about how many mobile phones need to be procured or purchased for the next month. So that is the report they can take from this data warehouse reporting system. But as I have told you in the last example, people are very impressed and they were satisfied to purchase that product, that is the mobile phone. But they hated, some of the people hated their delivery system. That information is fed in the form of the social media network, that is in the form of a structured or unstructured different formats. Okay, this data needs to be gathered and stored in this big data system, file system, so that here this again by applying some models of algorithms, that is data science algorithms, so they will be providing some recommendations to these e-commerce application users by they have powered some of the other products along with this mobile phone, like 80% screen guards and 70% covers. So that's how this data is going to be after applying the modeling, then the recommendations data also going to store in the local system, so that it is very easy to get the information. And to handle such big volumes of data from the social media network data, they need this Hadoop file system that contains two major parts, as I told you. For storing HDFS file system is required. To process that information or that big data, we need the model called the processing, that is MapReduce. So these are the main two parts in this Hadoop file system. That's what we are discussing now. Okay, this processing mechanism is doing through this distributed algorithms on a cluster. Okay, and this basic unit of information used in this MapReduce is called a key value pair. All types of data, it may be a structured data or unstructured data, need to be translated into this basic unit of information before feeding this data to this MapReduce model. Okay, this MapReduce model consists of two separate routines. This contains two separate routines. Okay, those are called map function, sorry, and reduce function. Map function and reduce function. Okay, so let us say that can be this MapReduce logic here, unlike the other data frameworks logic, it is not restricted to just structured data sets. It is also handling the unstructured data as well. Okay, so this map stage in this, here, let us show. I'll show you one diagram so that you can easily understand that. I have stored that here in this MapReduce. See, this is a small image, but I'll remember. I'll just here. This is the map function and this is the reduce function. In between, there is a shuffling mechanism. Okay, to sort or to merge the data together and get the results as the output. Okay, these are the two main components used in this MapReduce, map and reduce, map function and reduce function. Okay, and this is called, this has three stages here. One is the map stage and the shuffle stage and the reduce stage. Okay, this map and shuffle phases distribute the data and the reduce phase performs the computation, the actual computation. Okay, and this map reduce logic here can be applied not only for the structured data, it can be applied for unstructured data also. Okay, in this map stage, it brings the structure. Suppose, let us say, a counting of a paragraph on a on my laptop, counting of the number of words on that particular. This is the mainly used example, because for that purpose only their Google system was implemented this functionality, because when you search a word in a Google search engine, it is going to search in so much data, huge data. So for them, this architecture is required. So that's why I am explaining the same example here. Suppose, let us say, to count the number of paragraphs, suppose words in a sentence. Okay, or if we wanted to find the number of photographs stored in our machine, so that is unstructured data, and the counting of words is a structured data. We can apply the same mechanism on both the types of data, but For these two purposes, we need to maintain that data in the form of key value pairs. Okay. So let us say in this here, I told you here, suppose let us say to count the number of photographs on my laptop by the location wise where the photo was taken. Okay. So I need to analyze this unstructured data. Okay. The mapper makes here the map function makes key and value pairs from the data set. In this case, key will be the location and the value will be the photograph. After mapping is done with this task, we have a structure to the entire data set. So that is one example. In this map stage, the mapper takes a single key value as an input and produces any number of key value pairs as output. Okay. So I am just telling that example in a theory. I'll show you one diagrammatic way. Suppose there is a word to count the number of words in a sentence. Let us say we have a word that is we have the following two. There are three sentences. Okay. Uh, like the following one is a quick brown in fox. Big brown fox. The second one is the second sentence. The fox ate the mouse. The third sentence is how now brown crow. Let us say these are the three words or three sentences. Now I wanted to count the frequency of each word in all the sentences. How many times each word is repeated by using this map reduce functionality. You got my point? This is our task. Okay. So our objective is to count the frequency of each word in all the sentences. Imagine that each of these sentences acquire huge memory and hence are located in different data nodes. This mapper takes over this unstructured data or structured data and creates these values key value pairs. Key value pairs. Key value is nothing but, see, let us say, for example, here let us say here suppose for example here in this first sentence D is appeared one time, right? And the second key is like brown is one time. Likewise, fox is one time. Likewise, again, quick is one time. This is how the key value is going to store. Okay. In this first map node, generates 4 keys here. That is 4 keys here. 4 key value pairs here. That is 4 key value pairs here. This is the first key value, this is the second key value, this is the third key value, and the fourth key value pair. Okay. And the first three key value pairs are going to first reducer, and the last key value goes to the second reducer, like that. See, for example, here. Similarly, we have the second and third map functions do the mapping of for the other two sentences, that is the fox ate the mouse and the house now, the how now brown crow. This is going to count the same way. Okay, through shuffling all the similar words come to the same end. Once the key value pairs are sorted, the reducer function operates on this structured data to come up with a summary report. For example, suppose if you see the same example in a map reduce function, this is how it is going to operate. Okay. See here, we are giving three sentences as input. This is the first sentence, second sentence, and third sentence. This map function gets that data in the form of key values. As I told you, this is the first sentence, keys and values. Okay, and likewise here in the second sentence, here the here fox 8. See here, map 1, 2, 3. Three mapping functions are there here. And again here, after shuffling and sorting all this data, all these words, this became here, D is 1, brown is 1, and fox is 1. Here D is 1, fox is 1. And then these are going to store in this reduce function. Here it is getting this data. Here in the form of here, again the same format, that is key value format. And by using this reduce function, it is going to count the number of words in each sentence. Finally, we will get the output in the form of here, brown is appeared 2 times and fox is appeared 2 times, how is appeared 1 and how is appeared like this from this first reduce function. Like the second reduce function is going to here 8, co, mouse, pig. Okay, this is how the map reduce function is working in the Hadoop file system.
Sir, zoom out, please. We could see only a part of the screen, not the whole diagram. Kindly zoom out, please. Yes.
Is it okay now?
Thank you, sir. Yes, fine. Yeah.
Fine. Okay, fine. So this is the input we have given as 3 sentences, and this is going to store in a data node, right? And after processing this data with the help of map and reduce functions, in between we are going to apply this shuffle and sort mechanisms, so that this entire 3 sentences word count will be our output from these reduce functions. So that is how the map reduce mechanism works. Okay. And this mechanism is used in the industry, that is by using at Google, like index building for each Google search, an article clustering for Google News, statistical machine translation, and then in Yahoo they use for index building purpose, and spam detection in the Yahoo mails. Okay, and at Facebook they are using for data mining purpose, ad optimization purpose, and spam detection. These are the examples. And at Amazon they are going to use it in a product clustering and statistical machine translation. As I told you here, the recommendations are storing are going to process in the Hadoop file system, and that is again after coming that output, that is going to store in this local database, so that it's very easy to, whenever you search an item, the automatically will get the recommendations in the below of that e-commerce website. So why you are getting, how you are getting that, quickly, that bit faster, means that data is already processed in the Hadoop file system using map reduce functions, and then the result is stored in the local database. That's how this entire architecture is built. Using this, for storing the data, they use the HDFS file system, and for processing, they use this map reduce mechanisms. Okay. But again, later, this also has some limitations. That's why, again, this Spark came into picture. That we will discuss slowly. First of all, you need to understand these basic concepts in the Hadoop file system, as well as the storage, as well as the processing mechanisms. Okay. Now, let us come to uh, this modern data architecture. This is very important concept. This is also becoming, like a theory part, but don't get bored, because these fundamentals are very important. Okay, see, what is a data mart? What is a data lake? Also, what is data warehouse is also important. Data warehouse is the first one. Data warehouse, data mart, data lake, data pipelines, data mesh, and data lake house. These are the technologies which are right now is running in the industry. What is a data warehouse? Basically, the traditional data warehouse contains a repository, a centralized repository, by collecting all this data from data sources, different data sources. Actually, this is a online transaction processing systems like OLTP systems. All this data stored in the form of tables only, a structured data only, and after applying some extract, transformation, and loading using different tools like Informatica, Talent, okay, and some Abincio. Those are the different traditional tools for processing this ETL work, ETL, extract, transform, and load. And after transforming that data, that is going to store in this data warehouse. This data warehouse is also containing some data models like dimensional modeling, that is not going to store all the data from the sources. It is going to store only the historical data in the form of aggregation format, a summary data which contains only some fact tables and dimension tables. Okay, that you don't need to remember all those things. When data modeling comes into that sessions, I'll tell you about those things. What is a data modeling and dimensional modeling? Okay, and at the end of this uh, now output, these users are going to use the data for analysis purpose, or for reporting purpose, or for data mining purpose. This is the traditional way of storing and extracting the data, historical data, in the form of a data warehouse. See, let us say a data warehouse is a centralized repository that stores the large amounts of structured and semi-structured data from various sources within an organization. It is designed to support business intelligence activities such as data analysis, reporting, and decision making. Okay, to improvise their company's cost, or the company's revenue, to generate more revenue. And this data warehouse typically employ a process known as extract, transform, and load (ETL) to acquire data from different operational systems and cleanse that data and transform it to meet their specific requirements, and then load it into the data warehouse. See why this transformation is required? Because data may be feed now by human mistakes will be there, some errors will be there. So some after applying some validations on the data and formatting the data is going to store in the data warehouse finally. And this ETL process often involve the data integration, data quality checks, data transformations, and data aggregations. So these are the traditional mechanism which is used in the data warehouse. Okay, and then data mart. Data mart is nothing but a subset of a data warehouse. See, this is a data warehouse. In that data warehouse, data marts are nothing but it contains only some particular domain data like purchasing data, sales data, inventory data. These are the data marts basically. To process this data, the same concept ETL process is going to place in this from the operational systems, from the sources, these relational databases data of transparent data is going to store. There is a middle layer called staging layer. So here the actual ETL process is going to take place. The same process what we applied in the data warehouse. The same mechanism. But in this data warehouse, It contains some metadata, data about data, as well as summary data and some raw data. This again is going to store in a department wise or the domain wise, so that the particular department users can be accessed for their analysis purpose or for reporting purpose or mining purpose. This is a data mart. See, a data mart is a subset or a specialized version of data warehouse. It is focused on a specific business function or department within an organization, providing a more tailored and targeted view of the data. And data marts are created by selecting and aggregating relevant data from the data warehouse and transforming it into to align with the requirements of the specific business area only. As I told you, this contains only specific business area. This data mart contains only purchasing information. This data mart contains only sales information. As I told you, these data marts are the subset of a data warehouse. The mechanism is same, ETL process only. Understood this? This is the data mart. And the third one is here, the benefits of here. Okay, let us go to the data lake, because here there are so many data, main characteristics are there. Just we can go through it. I'll share with you this uh, slides or the PPT. Focus and the simplified access, improved performance. These are the different characteristics and benefits of data marts. Okay, if you wanted to read me, I'll read you. Data marts are designed to address the specific analytical needs of a particular business function or department, such as sales, marketing, finance, or human resources. Okay, they provide a more granular and targeted view of the data, enabling users to access and analyze the information most relevant to their needs. So this is the main focus of the data marts. And data marts offer a simplified and user-friendly interface for accessing and querying data. They often employ predefined reports, dashboards, and data models tailored to the requirements of a specific user group, making it easier for users to retrieve the necessary information without complex queries or technical expertise. See, when I am working in a company called uh, that is a big giant in the Saudi Arabia. I forgot that name. Long ago, I went there, and we have built some data marts and data warehouse to actually they have a large electronics electronics business company. So they wanted to know their inventory system and the sales reports through these data marts. So I have built that using Informatica as an ETL tool, and also as a at that time my role was ETL developer. As an ETL developer, you need to understand and you need to be able to generate some reports by using some business intelligence tools. Also, I was used at that time. Cognos is a business intelligence tool. So as a data engineer, you need to learn some basic concepts of some reporting tools like Tableau or Power BI. So these are the industry's popular softwares nowadays. They are using it. Just you need to remember. You need to just know the concepts. No need to work on those tools. Okay, but as and when a requirement comes, you need to be able to understand and provide that information to the end users. So that's how it is a multifaceted role as a data engineer. And coming to this improved performance, by containing a subset of data marts can be optimized for faster query performance, aggregating and summarizing the data at the data mart level that reduce complexity and volume of data, resulting in quicker response times for analytical queries. And enhanced data governance. Data marts can be managed and governed independently, allowing business units to have more control over the data. This can facilitate data ownership, accountability, and compliance with regulatory requirements specific to a particular department. Okay, and you need to understand those rules and regulations for that particular data. Suppose if we have a hospital management data, and then you need to have some, US, there are so many standards they maintain. So you need to understand those compliances also. You need to have some knowledge on that particular governance rules, data governance rules. And flexibility and agility. Data marts offer flexibility in terms of customization and adaptability. They can be quickly modified or expanded to meet evolving business needs, providing agility in responding to changing requirements without impacting the overall data warehouse architecture. So that is the flexibility and agility of these data marts. Cost effectiveness. Since data marts are focused on specific business areas, they require fewer resources and infrastructure compared to the comprehensive data warehouse. This can lead to a cost savings in terms of storage, processing, and maintenance. And there are some more characteristics are there. The benefits are there of this data marts. Coming to data lake, this is the important concept, and this is where we are going to work in the upcoming sessions in AWS. How we are going to create a data lake. Actually, this data lake is a centralized repository that stores large volumes of structured, semi-structured, and unstructured data in its raw or native format. Unlike a data warehouse or data mart, which follows a predefined schema and structure, a data lake allows for the storage of data in its original form without the need for upfront transformation or normalization. Because here they use some concepts called ELT concepts also, not only ETL, they use some ELT concepts also. The difference of ETL and ELT, there is no time. I'll discuss those concepts in the next session. So this is the data lake architecture. These are the different sources. These sources may be business applications, source enterprise data warehouse, multiple documents, SaaS applications, okay, like Salesforce applications, and device logs and IoT sensors. These are feeded or extracted and stored as a raw data format in this layer. Okay, this is called a data lake. After getting the data, see, that is called ELT process basically. Extract and load, then only process the transformations. And this layer, data processing layer contains indexed, and then here object storage, metadata storage, replications. So for these purpose in AWS, we use S3 bucket as a storage tool to store this data lake information. After applying the transformations by using map functions or lambda functions, those are called the serverless processing tools. I'll tell you what is serverless mechanism and how it is done with the help of lambda functions in the upcoming sessions. So finally, in the target, the data is stored in this targeted enterprise data warehouse for analytics purpose and data visualization purpose, data science projects through using APIs. So to perform this entire task, our job as a data engineer is to learn those tools, any one of the cloud platform that you have chosen a right platform, that is AWS. That can be done in any other data cloud platforms like Azure, or suppose if you go for OpenStack, we can use Hadoop, okay, Spark, and if you go for IBM, they have their own tools. If we go for so many cloud platforms are there. Oracle has their own platform, and Informatica has their own cloud platforms. But majorly, people are using this AWS. Okay, and you have any doubts, please. We'll continue in the next session, remaining topics.